SSH hardening is easy to get wrong because one bad line can lock you out of your own server. In this grepwise tutorial, we harden a fresh Debian SSH server step by step, verify every change before restart, and keep the session defensive and reversible. The goal is not a magic one-liner. The goal is an operator-safe sequence you can repeat on a real box while keeping a recovery path open. The order matters. First, inspect the service you actually have. Then, add a key before disabling passwords. Then, validate the SSH config before restart. Only after that do we add noise reduction, banning, and a firewall rule for the final port. If you change that order, the commands may still be correct, but the procedure becomes risky. Safe hardening is about sequencing as much as syntax. Start by proving what is running. We check the SSH unit, install only the small networking tool needed for inspection, look at the listening socket, and print the SSH settings that matter. This is the baseline we compare against after every hardening step. Notice that nothing here changes authentication yet. Before you touch access control, you want facts. Which unit is active, which port is open, and which config files currently define behavior. Do not turn off password login until a key is in place. In production, you would add your real public key through Cloud Init, Configuration Management, your hosting provider's console, or a second open admin session. Here the target is disposable, so we generate a demo key inside the container. The important habit is the same. Make sure key-based access exists before you remove the fallback. Now we create an ed25519 key and install its public half into authorized keys. This is not simulated output. SSH keygen creates real files. The permissions are applied to a real.ssh directory, and the final command shows the actual public key prefix that was installed. On a real server, you would test a new SSH login from a second terminal before closing the first one. Use drop-in files instead of editing the vendor file directly. Drop-ins are short, auditable, and easy to remove during recovery. They also survive package updates more cleanly because the distribution-owned file stays close to default. The critical safety check is sshd-t. If syntax is wrong, do not restart. A failed validation is a warning before damage, not an outage after damage. This drop-in disables direct root login and password authentication. Then, sshd validates the complete configuration, including the main file and every drop-in. Only after the OK do we restart and confirm that SSH came back active. This is the pattern to memorize. Write a tiny change, validate the whole daemon config, restart once, and immediately check service health before moving on. Changing the SSH port is not security by itself. A determined client can scan all ports. But moving away from 22 can reduce background noise from commodity scans, which makes logs easier to read and alerting less noisy. Treat it as operational cleanup, not as a replacement for keys, patching, logging, or least privilege. We add a separate port drop-in, validate again, restart, and inspect the listening socket. The server now listens on 2222, and every later layer must allow that port instead of the default. This is why the firewall comes later, not earlier. First prove where SSH is listening, then write the firewall rule that matches reality. Keys stop password guessing from working. Failed ban lowers the cost of noisy clients by banning repeated failures and keeping repeated log spam out of your way. It is not magic, and it does not replace good authentication, but it is a useful defensive layer when paired with real SSH hardening, especially on small public servers that live directly on the internet. Fail2ban is installed for real with quiet apt output. Then, a tiny local jail enables SSH monitoring on the new port, starts the service, and asks fail2ban for the live status of the SSHD jail. The status output matters because it proves the jail exists, the filter is loaded, and the action layer is ready. In production, you would also test with your logging backend and retention policy. The firewall comes last. If you enable it before allowing the final SSH port, you can lock yourself out even when your SSH configuration is perfect. The safe pattern is default deny. Allow the verified SSH port, then enable and inspect the result. On a remote server, keep the existing SSH session open until a second connection through the firewall succeeds. Finally, we add a firewall layer. UFW is available in this privileged throwaway container, so we set the default deny policy. Allow TCP 2222, enable it, and print the verbose status. The important part is the order shown on screen. The allow rule is present before the firewall is enabled, and the status proves the active rules match the hardened SSH port. The final checklist is simple. Keep keys working. Keep one session open while changing SSH. Validate config before restart. Document port changes, and put banning plus firewall rules behind the verified service. If you manage multiple servers, turn this into automation only after you have practiced the manual sequence and the rollback. Hardened is not one command. Hardened is a safe sequence, repeated carefully.